Hello everyone, I am Satyasekhar, a developer advocate with Salesforce. Today, I will show you how to create a custom user interface using Lightning Web Components. You can connect with us through various channels. The first one is our developer website, where you can find awesome content in the form of blogs, podcasts, documentation, learning resources, and much more. You can also reach us on Twitter as Salesforce Devs. You can follow us on Facebook, LinkedIn, and YouTube channels where you can find the latest updates and videos. Before I begin, I want to give a quick reminder that customers should base their purchasing decisions on products and services that are currently available. Let's start with a simple question. What is Lightning Web Components? Lightning Web Components is a modern open source UI framework. It is built on web standards. It is a new framework with which every JavaScript developer can now code on Salesforce. While you read it, you can notice that the first letter of each word is capitalized, and in short, it can be called as LWC framework. We can use this LWC framework to create custom HTML elements. We can call these elements Lightning Web Components, written in a small case. These components can be used on and off the Salesforce platform. To understand LWC even better, let's rewind the clock and check how the world of web development has changed over years. In the early 2010s, there was a lack of standards as illustrated in the blue compartment. The frameworks were created by implementing a lot of custom functionality to build the components. Here shown in green color. During this period, a lot of frameworks evolved. Each of these frameworks were apparently treated as a language. This caused many problems. Components built on each of the frameworks are not interoperable. Skills are not transferable. It is hard to find skilled programmers in each of these frameworks. But the world of development has changed rapidly since 2015. More standards evolved, which implies less proprietary stuff to learn. As standards evolved, more features are provided by the native browsers, which led to a great improvement of the performance, thanks to the browsers. It also brings us various other benefits, including the common component model, transferable skills, interoperable components, etc. Web components are based on these standards and derive all the benefits of these standards. Salesforce has adopted these standards early and built a new framework called Lightning Web Components with all the necessary functionality. You can create reusable components in the form of custom elements with these Lightning Web Components framework. It is bundled with styling, security, etc. With LWC framework, the amount of code that you write is very less for implementing a feature. Not only that, LWC framework provides all the required polyfills when you run your application on certain older compatible browsers that does not support ES6 Plus standards. Let's see how we can build more complex pages on Salesforce core using these reusable components. An application page can contain one or more functional components. These components can be called as experience components, which are made of one or more base components. LWC provides these base components, which are the basic building blocks accessible to programmatic developers through code. For example, icons, buttons, badges, avatars, and more. You can use these base components to build the experience components such as the news widget, report chart, related list, and whatnot. These components can be made accessible to other programmers to reuse. Declarative developers can use these experience components to build and customize the pages dynamically. They can also use these experience components in flows, utility bar, etc. Salesforce also provides a powerful tool on the platform with which you can build your own page. This tool is called Lightning App Builder. In the left pane, you can see some of the experience components that you can drag and drop to build your pages. You can customize the properties of this page and the components used on this page. You can also customize this page for a desktop and the mobile user interface and preview it. All of this from a single tool. Before we jump into the demo, Let's see what a typical lighting web component bundle can contain. You can define the user interface using an HTML file. You can write your components logic in a JavaScript file. This is the only file required if you are building a utility component besides the metadata file when you are using LWC on the Salesforce platform. The metadata file is an XML file where you can define all the Salesforce platform related configurations. You can also optionally create your own styles for your component using a CSS file. You can also optionally define the icon for the component using an SVG file, which will be reflected in your Lightning app builder. Now let's jump into the demo. Here we are in a sample gallery. It is a collection of sample apps that are reference applications. These apps are implemented by following the best practices and patterns. They are updated frequently with the latest features. Each tile contains the name of the app, description, and the features used in the app. It also has a link to the repository on GitHub. This LWC recipes app shows a collection of easy to digest code examples for Lightning Web Components. Almost all the recipes are built with less than 30 lines of code. You can find a recipe for specific tasks, starting with a basic Hello World example to the most advanced tasks and use cases. Today, we'll use this app to learn the Lightning Web Components. Let's click View on the GitHub link. This is the repository of the LWC recipes app. Every sample app repository has a README file, which provides step-by-step, easy-to-follow instructions to install the application. You can deploy the application, see how it works, and learn from there. I've already deployed the application by following the instructions in this README, and here I am in the deployed LWC recipes app. You can see that this app has various tabs, each tab showing a specific type of example. For instance, the Hello tab has some basic examples. Apex tab has examples where Apex code is involved. Similarly, child to parent and parent to child have component communication examples. Let's start with a simple recipe. This recipe displays a greeting message. If we inspect the DOM of this component, you can see that it is rendered as a custom element. This is one of the many web standards implemented by the Lightning Web Components. Like here, you can see the C-hello tag. Now let's see how to code. Here I am in Visual Studio Code. You can use any code editor of your choice. I am using VS Code as it is a lightweight IDE, and you can install the Salesforce extension pack, which contains the necessary tools and features that can be used to build any app on the platform. Let's now look at the component structure. You can see that this component is built using the HTML and JavaScript file. Also, notice that this uses a camel case naming convention for the component. This name will be rendered in a kebab case when it is rendered in the browser. Kebab case is where the words are separated with a hyphen. Let's open this JavaScript file. As I said earlier, LWC leverage web standards. Starting here, we are importing the Lightning element using standard ES6 syntax. It also uses standard ES6 classes. Here, we are extending Lightning element so that we can create a custom element. The Hello class has a property named greeting initialized to world. Now, let's take a look at the HTML file. Here we are using a standard HTML element called template. Here you can see that we are using the pre-built base component lightning card tag for the layout. I have picked this from the component library. To bind a component property like greeting here to an HTML element, you use the simple bracket syntax. Now let's go to the component library and look into the documentation of base components. You can find the base components under the Lightning namespace. Let's search for the card component that we have used. Here we have an example, documentation, and specification for this component. You can see the description, and when you click this drop down, you can see all the variants of the components. Here you can see the preview of the component. At the bottom, you can see the Lightning mini playground. You can make the changes to the example, and you can see the changes applied dynamically in the preview. Now you can copy this code and use it in your component. It also has elaborate documentation with more examples. You can refer to the specification to see what properties can be used in the component. Let's take a look at a slightly more sophisticated component. Here, the user can change the value of the greeting property. Let's look at the code. Let's search for the file by using Command P on Mac or Control P on Windows. Like the earlier example, we are defining a greeting property. The properties are reactive by nature, which means that when the greeting property changes, the template automatically re-renders to show the new value in the HTML view. The handle change event handler is called when the user types a new value in the input field. Here we are simply updating the value of the greeting property. Let's take a look at the HTML file. When greeting changes, the hello message automatically changes because the greeting property is reactive. And when the user types a new value in the input field, it fires an event which is handled by the handle change listener, where the greeting property is updated. How about accessing data? In this next recipe, we'll learn how to retrieve a list of records, in this case contacts, using an Apex method. Apex is an object-oriented programming language used on Salesforce to work with data. To learn more about Apex, you can watch the video Automate Your App with and Without Code, and you can find the video in the same playlist of this series. By the way, how many lines of code do you think we'll need for this? Let's take a look. Let's search for the file by using Command P on Mac or Control P on Windows. First, you import the getContactList Apex method as a module to make it available in your JavaScript code. Let's look into this contact controller Apex class. Here you can see that we are returning a list of contact records. You can then wire this getContactList method to the contacts property. That's it. The property is reactive. When its value changes, the view is automatically updated. Let's see the HTML file now. Here we are using template directive for each to iterate through the list of records that were written by our Apex class. Lightning Web Components is open sourced, which means you can use the same framework on and off the Salesforce platform. For instance, you can build engaging apps on Heroku or any platform using the backend language of your choice. The source code is available on GitHub, and you can also contribute your ideas and code by submitting the pull requests. You can start building by visiting lwc.dev site, where you can find a developer guide. So let's see how we can learn and build the application using LWC OSS. Here I have opened the lwc.dev site. You can install the LWC library and create the project using a simple open source tool called Create LWC App. With this tool, you can also run the app locally, and not only that, with hot reloading, you can dynamically watch the changes while you code. Let's see that in action. I'll copy this command and switch to VS Code. We'll run the command from the terminal to create an app. It will launch a wizard. We can accept all the default values to create a standard project. You can also create the project with the desired configurations. It does a little bit of processing and creates a project scaffolding. Let's open the project folder in VS Code. You can see the project structure, and you can also notice that it has created a package.json file. This file has all the project configurations and dependencies. If you scroll down, you can see various scripts to build, run, and test our app. We'll use the watch command to run the LWC services. Let's now see the code. It created a default namespace named my, and within that it has created a sample component called greeting. You can see that it is similar to the hello component that we saw earlier. From the terminal, let's execute npm run watch. It will start a local server. Let's open the browser by the side of VS Code. Let's open this URL in the browser, and it shows the sample component in the app. Let's change the greeting message from hello to hi. Now we can see that it dynamically reloads by rendering the new values. You can check this complete developer guide, which starts with basics. You can find easy to digest, bite-sized examples throughout this guide. Each of the code snippets in the guide can be dynamically edited. That means you can modify those examples while you are reading and see how it works. You can click this recipes link to see a live app deployed on Heroku with a collection of open source examples. This app is pretty much equivalent to the LWC recipes app that we have earlier deployed on the platform. You can also view the source of each of these recipes on GitHub. Here you can see the test folder, HTML file, and JavaScript file for this recipe. You now know that LWC is a modern UI framework built on web standards. You can use LWC to create custom HTML elements. You can use one or more base components to build more complex custom components. Now, every JavaScript developer can build reusable web components by deriving all the benefits from LWC framework. They can then deploy it on Heroku or any platform using the backend language of their choice. And the good part is, you can find the source code on GitHub for tools that we have used, recipes, base components, and also the LWC framework itself. You can check out the sample code from the sample gallery, tailor it for your purposes, and use it. If you find a bug in a recipe, or if you cook a new useful recipe by yourself, you can also contribute to the source code. You can get started with Lightning Web Components on Trailhead, the fun learning platform, as you all know, by visiting sfdc.co/LWC. You can also get started with Lightning Web Components open source by visiting sfdc.co/LWCOSS. Thank you for watching, and remember to like the video and connect with us in our social channels if you like this session. If you want to get more content like this pushed directly to you, subscribe to our channel and click the bell icon to get notifications. Also, let us know in comments which key learning did you have from this video and what are you going to learn next. Thank you and see you in another video.